Alright, so we're going to work through the Chapter 2 practice tests, and those are just a kind of list of the topics. The whole chapter is on solving linear equations and inequalities, and you can see the topics for each of 2.1 to 2.8 right there. So 2.1 is dealing with something called a function. When you see something like w of -9, that just means wherever there's an x in this equation, in this function, you replace it with the number -9. So 4 times -9 plus 5, 4 times -9 is -36, and -36 plus 5, that is equal to -31. So that's how you would do this one. The next one, p of 2, means wherever I see an n in this equation, I would plug in 2. So p of 2 is just a faster way of saying plug in 2 for n. So 2 minus 3, and that equals -1. Okay, the next two are done similarly, just with exponents. You have to be careful when you're dealing with exponents and squaring them. So this says wherever I see a t, and I see a t in two places, I will plug in -1. So that's -1 squared plus 2 times -1. The reason I put that in parentheses is because if you enter this in a calculator, it's going to be -1. This means -1 times 1 squared. That's not what you want right here. So -1 squared is +1. Plus 2 times -1 is -2, and 1 plus -2 gives you -1 as your answer. Alright, this one right here, wherever I see an x, I'm going to plug in the number 8. So I get 8 squared plus 3 times 8. 8 squared is 64, and 3 times 8 is 24. 64 plus 24 equals 88. Okay, these are similar problems again, but just with a different type of function. This is an exponent function now. So this time, wherever I see a t, I'm going to plug in the number 2. So 5 to the 2 plus 3. 5 squared is 25, and 25 plus 3 equals 28. Number 6, wherever I see an x, I'm going to plug in the number 10. So negative absolute value of 10 minus 2. The absolute value of 10 is just 10, and then with that negative in front, it becomes -10. And -10 minus 2 is -12. Okay, these ones are a little bit trickier. Now instead of plugging in numbers, you have to plug in entire expressions. So this one says wherever I see a t, I'm going to replace it with this thing right here. So what that ends up being is -3 times 2 to this thing, to the 2 to the -1 minus t. And that's all you can do. You can't get a number out of that because what they told you to plug in was this. They told you to plug in something with t, so you should get a t still in there. Okay, this one's a little bit trickier, so this time wherever I see an n, I'm going to plug in an n minus 2. So what I like to do is leave a big parentheses where there used to be that n right there, and then that will remind me that I need to plug in this thing. I need to plug in n minus 2 right here. Okay, the way that we would simplify this now, we'd have -3, n minus 2 squared looks like this. N minus 2 squared is n minus 2 times n minus 2, and we still have that plus 2 right there. So then what we need to do is FOIL this out. So if we FOIL this, n times n is n squared, n times -2 is -2n, -2 times n is again -2n, and -2 times -2 is +4. So then we can just simplify this a little bit more. So we have -3, -2n minus 2n would be -4n. And then if we distribute the -3 times n squared would be this. -3 times -4n would be +12n. -3 times 4 would be -12, and then we still have that +2. So the final result would be -3n squared plus 12n. -12 plus 2 would be -10. So that is as simple as we can make it. We should still have n's in our answer because we started out with n's in what we were supposed to plug in. Alright, the rules for whether something is a function is if each x has only one y. And then for something to be a one-to-one function, it has to be the reverse is true also. Each y has only one x. So I'm going to take these x's right here and just list them, because this will sometimes help to be able to just draw arrows from one to the next. Okay, so those are our x values right there. And then our y values are these, 7, 8, 9, 9, and 1. So 7, 8, 9. I'm not going to write the 9 twice. We just need to write it once. And then I'm going to draw arrows connecting each x. So it looks like 2 goes to 7. So there's an arrow right there. And actually, I made a mistake here. We don't need to duplicate that 5 either. 5 only needs to be, there's 2 5s here and here. We don't need to go more than one. So 5 points to 8. But notice 5 also points to 1 down here. Okay, negative 3 points to 9, and then 9 also points to 9. So this is not a function, and the reason it's not a function is because each x is only allowed to have one y. This x has only one y. This x has two y's though, so that is not a function. Okay, so we would pick neither. You can ignore this and a, that doesn't apply. Okay, if the 5 wasn't there, if this thing weren't here at all, then it would be a function. It would not be a one-to-one function though, because this number here, this output has two inputs coming from it. So if that 5 weren't there for x, it would be a function, but it would not be a one-to-one function. Okay, this right here, it says write in standard form. This is what standard form looks like. And the key with standard form is a cannot be a negative number, and we also can't have any fractions here. Okay, if there are any fractions, or if a is negative, it doesn't count as standard. Okay, and then also we want the c, we want the number to be on its own side. So I'm going to move this 1 over so it's on its own side right there, and we're left with negative 2/15 x plus 1/3 y. Okay, this is important. We can't have any fractions, so what can I do to get rid of the fractions? Well, I see that there's a 15 and there's a 3, so I could multiply this by something that would cause both of those to disappear, and that would be 15, because 15 cancels with itself once, and 3 goes into 15 5 times. So the 5 is going to get distributed here. Remember, it only canceled once with that 15, so let me actually use a different color for this. When we cancel this 15 with that 15, we just get a 1. So 1 gets distributed to that. We have negative 2x. Okay, then we have the 15 canceling with this, and that became a 5, because 3 goes into itself once, 3 goes into 15 5 times. So 5 times the 1y would be 5y. And then remember, whatever I do to one side of the equation, I must also do to the other. So 15 times that would be negative 15. It's almost in standard form. The only problem is this right here. A can't be negative, and right now this number is a, it is negative. Easy way to solve that is just multiply everything times negative 1. So negative 1 times negative 15 is 15. Negative 1 times that is 2x. Negative 1 times that is negative 5y, and now that's in standard form. And that's what it is. They just wrote it in with the 15 on the right instead of the left. Alright, for these we want to sketch the graph of the line, and it's easiest to do this when you put it in slope-intercept form. Right now it's in standard form. This is slope-intercept form. So slope-intercept means we've solved for y. So I want to get this by itself, which means I'll move the minus 4x, or I'll move the 4x over by subtracting it. And so we're left with this. Then I want it to be y equals, not negative 3y equals. So to get rid of the negative 3, I divide by negative 3. And we're going to get y equals negative over negative cancels and becomes positive 4 over 3x. 6 over negative 3 is minus 2. So there's our slope-intercept form. The intercept, the y-intercept, is right there. It's negative 2, so I'm going to put a dot at negative 2. And the slope, the m, is right there. And remember, slope is rise over run. So that means we're going to rise up 4, and we're going to go over to the right 3. So 1, 2, 3, 4, 1, 2, 3, over. All we need is 2 points, and then we just connect the dots, and we're done. Okay, the next one is done very similar. So first, let's move this over so it can be in slope-intercept form. So we have negative 5y. Don't forget that this negative still needs to be there. And then I'm going to put the negative 6x in front plus 10. Okay, then we need it to be solved for y equals, not negative 5y equals. So we'll divide everything by negative 10. Those will cancel. Negative over negative becomes positive 6 over 5. And then 10 divided by negative 5 is negative 2. That's my y-intercept, so I'll put one right there. This right here is the slope, and that means go up 6 and go over 5, which is where I just put that dot. And it's not a very neat looking line, but that is roughly what the line will look like. Just says sketch the graph. Okay, find the slope. Well, the slope is equal to m, which is, we said it's rise over run. And the formula for the rise is the change in the y's. The change means difference, so the difference in the y. So there's my first y, there's my second y. Over the run, over the change in the x. So here's my first x, here's my first y. It's important that if you chose this to be your first y, you have to choose that to be your first x. You can't mix them together. So y2 is this one, so negative 2 is going to go there. Minus y1, y1 is at 6, so minus 6. Negative 2 minus 6 is negative 8. x2 minus x1, here's my x2, 4, minus my x1 is minus negative 3, and minus a negative is like adding. So 4 plus 3 is 7, and we can just leave it like negative 8 over 7. Alright, this one says write it in slope-intercept form, which is, again, this right here. So first of all, the intercept is right here at negative 4, so I'm going to put a negative 4 right there. And the slope, it looks like we're going up 1, 2, 3, and over 1. So up 3 over 1. You could write that as 3 over 1, or you could just write it as 3, and that is the only option that fits, is D. Okay, let's do a few more here. So this is a similar problem. This time the intercept, these are different colors so we can see this a little bit better. The intercept right here is negative 3. So here's slope-intercept form again. This right here becomes negative 3. And then what is the slope? It looks like we're going up 1 and over 1, 2, 3, and that doesn't really meet. So we actually want to put it where it's right on the point. So here's, let's find one that's clearly on the line. This one is clearly on the line. So to get there, we go up 2 over 5. So up 2 over 5. That should be our answer. Let's make sure that is one of the options, and it is. It's option B. Alright, this one says write the slope-intercept form of the equation given through this point with this line. So here's our slope-intercept form. Okay, they gave us the slope already, so we can just plug that in right there. Okay, and the question is, how do we find the b? Because our final answer is supposed to have a number plugged in both for this and for this. The way that we find is we use this information. They told us that x coordinate on this line is 2, and the y coordinate at that point is negative 4. So we can just plug in, actually use a different color here. This is our y coordinate, so I'm going to plug in negative 4 right there. And then this is our x coordinate, so I'm going to plug in 2 right there. So 1/2 times 2, and then doing this we can solve for b. So half of 2 is 1. 1 plus b is negative 4. Let's subtract 1 from both sides, and negative 4 minus 1 is negative 5. That's what b equals. So now we go back up here, and all we need to do to finish this is just plug in that minus 5. And this right here would be our final answer. That's the line that has a intercept of, sorry, it has a point of 2, negative 4, and has a slope of 1/2. Y equals 1/2 x minus 5. Alright, a few more here. So it says write the slope-intercept form. This is almost the same. Y equals mx plus b. They're telling us that m is 3, so I'm going to plug in 3 right here. And then they're also telling us a point on this line. They're telling us that x is equal to 2, so I'm going to plug in 2 right there. And then they're also telling us that y at that point is equal to 1, so I'm going to plug in a 1 right there. Okay, and then all we need to do from there is just finish up by solving. So 3 times 2 is 6, and we'll subtract 6 from both sides. That means b is equal to 1 minus 6 is equal to negative 5. So all I need to do is put that in right there, where it said 3x plus b. I'm going to put 3x minus 5, and that should be our answer, and it is. Okay, point slope form. Point slope form is this right here. It's y minus y1 equals m times x minus x1. Okay, they did not give us an m, so we have to use the slope formula to find that. We just did that on the prior page. So this is x1, this is y1. Okay, so here's our slope formula again. Just kind of doing this in color coordinated, it's a little bit easier to see. And then here's x2, here's our second x, here's our second y. Okay, so there's our formula right there. So now all we need to do is just plug this stuff in. So let's do that. So y2 is negative 2, and y1 is negative 3. So negative 2 minus negative 3, that's like negative 2 plus 3. And then secondly, we have x2, which is 3, minus x1, which is negative 1. Okay, so finally, negative 2 plus 3 is 1, and 3 plus 1 is 4. So we have a slope of 1 over 4. So let's change this. Our m is 1 over 4. And then to find the x1 and the x2, we need to pick either of these 2 points right here. If we look at the options, it looks like they're dealing with y being 3 in several cases. And that looks like it matches this one. There isn't a case where y equals 1, so we have to get rid of that. So y minus y1 would be y minus, here's our y1 right here, y minus negative 3, that's like y plus 3. So that means this one must be wrong, because it's supposed to be a y plus 3. And then when y is 3, sorry, it's gotten so messy you can't see it, but x equals negative 1. Or x equals negative 1, so I'll plug that in right here. So minus negative 1, that's like x plus 1. And if you look at that equation right there, it matches option C. So that would be C right there. Alright, last two for this video, and then we'll change or finish the other ones in other videos. So this one says, same thing, it says find point slope form. Okay, so our slope is going to be y2 minus y1. So there's y2, there's y1. So 5 minus 3, which is equal to 2, over x2, negative 3, minus x1, which is negative 5. Negative 3 minus negative 5 is like negative 3 plus 5, which is 2. So that is a slope equal to 1. Actually, the only one that has a slope of 1 is right there. That's kind of like writing 1. But let's just verify that we get it completely here. So that is equal to 1 right there. And then if you plug in, let's try this point. If you plug in this point right here, y minus y1, y1 is 3. So let's replace that with a 3. X minus x1 is x1 minus negative 5, which is like plus 5. So this equation is equal to that right there, which is B. Alright, number 20 says write the slope-intercept form of the equation of this line. So here again is slope-intercept form. What we have to know is if this line, so we'll call this line A right here. This is the line they're giving us. We want to write a new line, which we'll call line B. And this is line B. What do we know about line B? We know that it's parallel to line A, and line A has a slope of 6 over 5. So what we have to know is that parallel lines have the same slope. That means this other line is going to have also a slope of 6 over 5. And then we also know, because they're telling us here, we also know that it goes through this point. It has that x and that y somewhere on its line. So let's plug that information in right here. So y is equal to 4, they told us here. And x is equal to 5, they told us right here. And then we want to solve for b. So these will cancel when you multiply them. You get 6 plus b equals 4. We subtract 6 from both sides, we get b equals 4 minus 6 is negative 2. So I go back up here, and I need to plug in a minus 2 right there. And that is our answer, y equals 6/5 x minus 2. That's the one that's parallel to that line right there. Alright, in the next video we will finish up the Chapter 2 practice test.